Hey there guys, a little quick update on the unification coil. Actually, this is the ABHA coil. So you can see the 15.9 watts input, 71.7 watts output. You can see the input equals 30 volts times 0.53 amps, and the output is 132 volt, 0.8 volts times 0.4 amps, and 71.7 watts. So the input is 15.9 watts, the output is 71.7 watts. That is a very large percentage of efficiency, upwards of 400+%. So you can see that the total power consumption is 27 watts. That means that right over there, the kilowatt meter is measuring 27 watts. This 15.9 watts minus 27 watts means it takes about 12 watts to run the amp, and that there's 15 watts of audio output going through this wire and then into the coil. So 15.9 watts going into the coil, and then measuring on the output or 71.7 watts. So we have a very, very efficient coil. This is the frequency generator, 2000 hertz going into the amp, and then of course going the audio out into the coil. Put audio frequency in, and you get power out, amplified power out, to the tune of a few 100% over unity. So this is fantastic. 27 watts total consumption, 70 watts, 71 plus watts output with a load to verify it. Very, very good news, guys. Alright, so we have the ABHA coil powering a UFO illuminator 200 watt grow light, which I've used for about 4 years, and it's a great light. I've had it actually growing vegetables and berries and herbs and all kind of things. It's a great light. You can get a 6x6x6 black mylar grow tent, and you can grow vegetables in your house. And now we've been able to actually light this light up with just using a total of 40 watts to fully light up the full light, which usually consumes about 200 watts. So as you can see, we'll kind of take a look at this. This power comes in here, through there, goes into kilowatt meter. That's measuring total power consumption. The amp has an input frequency coming from my computer of 2000 hertz, and that frequency goes into, through here, comes in there, goes in here to the coil, goes round and round and round, and it gets collects extra energy and comes out through these two wires here, comes over here into the Tesla cap, and then goes into the LED light, which is very bright. And basically we can see here the input is 32.86 watts, so it's actually less than the true 40 watts because it takes about 8 watts to run this amp. So really there's only about 32.86 input watts going in, and there's 177.28 watts being measured going out, which you divide the 32 into 177 and you get 539% efficiency. That means we're putting in 32.86 watts and getting out 177.28 watts. This is a very, very efficient ABHA coil. And now we're showing how it can be utilized to really, really reduce our power consumption when we're talking about growing food indoors using LED lights. This is a huge breakthrough, and we're going to be selling these soon as a complete system, and we'll just keep following our work. This is really exciting. Much love, peace, and blessings to all. So I've now plugged in another 191 LEDs, and it's only drawing another 6 watts. So I plugged in another 191 LEDs, and it's only drawing another 6 watts. As you can see, holy crap, that's bright. Basically, the bottom panel right here is 192, but not one of them broke, so I had to bypass it. So basically, that's 191 LEDs, and then the 200 watt, it's only pulling 177, but the 200 watt grow light. And that's still very bright as well. And so basically now we've been able to plug in the grow light and this other really bright light. I mean, super bright, 191, they're super bright LEDs. We're only drawing 6 more watts. So you can see the efficiency went up to about 580%. It seems as we plug more lights in, it's not drawing that much more power. So I mean, I'm not sure what the limit is. We need to plug some more LEDs in. This is blowing my mind. So the ABHA coil, you rock. We got lots of light. Whoa, look at that light. All right. Woohoo! Much love, peace, and blessings to all. So I've got a little accidental spark gap that happened when I hooked up this 250 watt light. Looks like a halogen type light. I didn't think it would light, but then I was messing around with the connection, and all of a sudden the energy jumped from the end of that lead. I started making a spark gap, and basically it's now pulling in more voltage and lighting that thing up. The input is 53 watts. That's going into the amp, which then goes into the speaker wire, the black speaker wire, which comes and goes into the coil, and it spins around, collects some electrostatic energy, radiant energy, and then it's being measured, the input, amps and volts. It's 1.3 amps in, 25 volts, 1.3 amps out, 381 volts out. So I think we need to put some spark gaps on the output of this to capture this radiant energy. It seems like that's what it's wanting to do. It's pretty amazing. Also, it's producing a ton of heat. So it's up into 244 range there. 244 degrees Fahrenheit. .350 degrees, 360 degrees Fahrenheit. As that spark gap comes into resonation and then falls off, you can see changes in input. Right now there's no gap, it's not connecting. And move this a little bit. It starts gapping. You can see immediately what happens there. There it goes again. Oh, there's a good one. Wow, yeah, it's a good spark gap right there. 1.3 amps. Going from 37 volts to 360, over 300 volts on the output with the same amp draw. And tons of heat. All for a total of 49 watts, plus it takes about 10 watts to run this amp, so it's really only about 40 watts. I think spark gaps are our friends.